So here's our third one for this batch. We're going to, so we've declared local variables, we've passed parameters to functions, and this one we're actually going to have a function that has a return value. So this function, again, simple program, doesn't do much. Literally all this thing does is just return the square, 5 squared. So in the main function here, we're using cout, and then we're using the fact that it's returning the function's returning a value to just output that return. Inside the function, all we have is a couple local variables, and then because we don't have a multiply operation in our Pep8, we're just going to do a loop here that's just going to loop through 5 times, adding 5 to our square, and then we're going to return that square. So let's take a look at the actual Pep8 part of it. So we'll start down here with the main. So in main, so the overall process is very similar to passing parameters. In the calling function, we got to make space for that return value. So we're going to actually, I'm actually putting a 0 in there. I don't have to have anything inside there. I don't have to have anything in that memory space, but it's that security thing. I just like to 0 it out before I call it. Um, so all I really needed to do was just subtract 2 to allocate space on the stack, and then call the function, and so the function would know that that space has been allocated, so that's where it would put the return value. When we come back from the function, just like before, first thing we do is deallocate that space on the stack, so we give it back. But think about that. That space is where our return value is, so we're deallocating it right away. But remember what, like we've seen in the other videos, the memory doesn't go away, it's still there, we can still get at it. And if we look down, if you remember, this is the cout command, so I'm couting a message that says 5 squared equals, and then there's my call. So down here, I just decimal output -2 on the stack. So even though I've deallocated the space, I just go ahead and grab it off the stack. So you could argue that it's, hey, you're using stack space that isn't allocated, but it's all under my control and I know right where it is. And it's not like I'm accessing some foreign location. It's just that I know it's there. And again, you could move the add SP down further, but it starts to complicate things a lot because then you have to keep track of, well, particularly if you had multiple parameters that were going in, and then potentially more local variables too. So again, it may not always seem the most logical way to do it, but it's pretty standard. It's what the compilers typically do. So let's jump up to the call. So just to recap here again, I allocated space on the stack for my return value, and then I made the call to the function. So we jump up here to the function, and we can see right there's where I'm using my equate. I'm setting my offset on it. So I've got 2 local variables, and just like always, the local actually, let me show you again just to see that there. So there's my 2 local variables, my int I and int sq. So I've got to allocate those just like we normally do. So, and they start at 0. So there's 2 local variables, 0 and 2. And then we see there's that hole in there again. So I'm going 0, 2. Normally you would think, all right, well, I'm going up by 2's. It's an integer, so my next one would be 4. But I skipped one. So it goes from 4, or so it goes from 2 to 6. So the 4 I skip over. And why do we do that? This one you're supposed to answer, but you can't. So I'll tell you. Remember, that's where we have that return address, and that return address that the call statement put on there, that's implicitly there. So if we forget that, and say if we forgot to do to leave that space in there and set our return value up at 4, that means we would be overwriting our return address. So when we got down to the end of the function, we'd be returning to some who knows where address. So you got to make allowances for that space. So there's the equates, there's the offsets like we normally have, there's the sub SP4 because we've got 2 local integers, so that's 4 bytes, so we allocate the 4 bytes. And again, I'm not going to go through the details of the actual body of this because the videos get way too long when I do that. So I'm just going to jump down here to say, all right, we're doing, well, I will cheat a little bit here. I'll go back here and look at the actual C++ program. So remember, here's our, whoops, I lost it. Somewhere in here is the C++ program. There it is. There's the C++ program. So there's the C++ program that, oh, I got copies of it now, that had the local variables inside there. And it actually is using SQ, one of those local variables, to accumulate that value. So that's where it's actually going to have the return value. So it's C++. So at the end of the function, we return that SQ. So the thing we have to do is get that SQ stored in the location of where the returning function or the calling function thinks it needs to be. So it really is pretty straightforward. We do all our calculations. By the time we get down to our end of our for loop, our SQ has the total value. So we load SQ into the accumulator, and then we just store it in our return value. So that, again, the return value we set the equate up here for. So essentially we treat it like a local variable. Um, Technically, if you were writing this thing from scratch, you could avoid the SQ and just use that return value. It's just that that's not how a compiler would do it. That's not how it would be processed. Normally, it's just not what you would normally see. Normally, you have a dedicated variable in there. But technically, you could. Don't do it, though. Do it this way. So when you get down to the end of the function, you have your calculated value, you store it in the return value, and then after that, you do the add sp4 here because we have the two local variables, we got to get rid of their space, and then the return just like we normally had, and then that gets us back down to our called function. And like I said earlier, we deallocate the space, and then when we want to use the value, we just use a -2. And it's always going to be a -2 because it's always the last thing that was on the stack. It's always that return value is always the last thing that went in. So let's go ahead and run this thing through just so we can watch the stack build. So I'll build, load, assemble, trace. So branch down to main. So everything's local this time, so I got no global memory. So first thing in main, I'm clearing, oops, I meant to go over here to the stack space. So the very first, well, I have nothing in there right now, so we can't see it, but the very first thing we have in here is storing a 0 at -2, so, well, we'll see it highlight. So it's going to highlight that location. Ooh, it double-clicked for some reason. We're going to highlight that the 0 got put in there. And then, shoot, it jumped too far. Sorry about that. There we go. It stored it did the -2, and then it did the sub sp2, so that's where it actually allocated space for that 0, and then it did the call. So there's my return value sitting all the way at the lowest point of the stack I have, return address above it. And now I've gotten up to the call, and now I'm getting ready to allocate space for my two local variables. So when I step that, there's my two local variables. So now, again, there's my stack with the SQ sitting at offset 0, the I sitting at offset 2, the return address, which I don't work with, but it's there at offset 4, and then the return value that I want at offset 6. And then, like we said before, I'm not gonna run through the actual details of the program here. Actually, here I'm going to use another feature. I'm going to actually check this little box here at the end 4. That's going to actually set a breakpoint, and I'm going to do resume, so it'll actually jump down to that location. So at this point, I've got 25. 5 squared is 25, so I've got my right number in there. I'm going to load it into the accumulator and then store it at my return value. So right now my return value is 0. If we looked over here, we can see it in the stack. When I do that single step, it's going to, it's in the accumulator, and I'm going to do single step, and it's going to store it. So there's my return value stored there and over there. And now I'm going to add SP and deallocate my local variables. I'm going to return 0, which is going to get rid of my return address. And now I'm back from my call, and now this is the one that's potentially scary because I'm going to do my add SP, which is going to get rid of my stack space from my return value. But remember, it's still sitting over here in memory, so even though I've allocated or deallocated space, it's off the stack, but it's still sitting right there in memory. So I output my 5, I output my message, my squared equal, and now I'm going to do a decimal output of stack relative minus 2. So there's my stack, there's my minus 2, which is 19, and hex, which is 25 in decimal. So it's again, I don't want to overblow it, but just using that minus 2 is no big deal. It's just how you get at that return value. And I guess that's it for this one. So I'll see you next time.